Hey everyone, welcome back, AI enthusiast. I'm your host, Adima Zokario, product design and AI expert and the creator of Online Leaders program, Unlocking the Power of Generative AI. And today we're shifting gears and exploring the exciting intersections of artificial intelligence and the automotive industry. Joining us is a hands-on technology and business leader with a passion for deep learning, computer vision, and things AI. With a PhD and background, he brings a unique perspective in how AI is shaping the future of cars, from self driving vehicles and intelligent safety features, and much, much beyond. Buckle up for an insightful ride into the world of automotive AI. And now, hi, Itai.
Hi, nice to meet you. Excited to be here.
I'm so happy that you're here with me. Dr. Itai Orr is the director of AI at UVAI. That's the name of the company. And I'm sure we're going to have an exciting talk. We're live on LinkedIn, YouTube, and Facebook. And you're so invited to join the discussion and ask questions. And now we can start. Tell me about UVI and what have you learned about creating AI products working there?
Sure. So UVI is a startup company. We specialize in automated vehicle inspection. We are currently about 200 people, mostly based in Israel and in the US. And we essentially revolutionized the way that car inspection is being made today. Our customers essentially have an experience of a drive-through. They drive their cars into their dealerships, or if we operate with fleets of vehicle. They drive their vehicle through our system. Our system takes a bunch of pictures all around the vehicle, from the sides, from below, from the back, from the front. And we automatically detect damages, severe damages, small damages. We inspect the wheels, we inspect the wear and tear, essentially give an MRI to the whole vehicle. And then report back within a few seconds on the status of the vehicle. If there are any severe damages, if the vehicle needs to be grounded, if there are safety issues, etc.
Yeah, and maintenance, especially to make sure that it doesn't get much worse, so forth, I guess.
Mhm.
And it's mainly for a fleet management tool or a dealership or a rental. I would guess like car rentals, for example, would need that, right? And it's all
So
based on computer vision.
yeah, so UVI has a large customer base. We have several hundreds of customers. We operate mostly in the US and Europe. We have several segments that we're active in, mostly fleets of vehicle, where we have a large amount of vehicles that operate from a single or multiple domain, multiple points of origin. And we also have a very active business activity with car dealerships all around the US, car rentals, and more.
I see. So the tool itself is based on vision, or you have any other kind of sensors? I don't know, like listening to the motor itself, or what kind of technology there is?
So mostly, currently, most of our activity is based around computer vision with cameras. But we are actively looking into incorporating new types of sensing modalities like acoustics, like maybe LiDAR, radars, and more.
I see. How is AI currently being used to enhance vehicle inspection and improve vehicle safety?
Sure. So most of our tech stack revolves around AI. So once we take the images from the sensors, we upload them to the cloud, or if we have an on-prem solution, that will be uploaded to the on-prem compute. And then we have a series of models, deep learning models that analyze the images and find all of those scratches, dents, severe damages, missing parts, stuff that shouldn't be there, and more. I would say that currently the tech stack is a combination of classical computer vision, deep learning, machine learning, and recently also generative AI. And I think that in the larger context, our solution really automates and enhances worker productivity. If we look at how things were done before UVI around fleet maintenance and car inspection, it was mostly manual work. You had a person walking around the vehicle. If he has the facility, he can look under the vehicle. Not every facility has those equipment. And once you have UVI, you don't need all of those special equipments, and you just drive through, like in McDonald's. You just drive through the sensors, and we automatically inspect everything. I think that
Mhm.
the dramatic, I would say the most dramatic influence from my perspective is the speed at which we do the inspection. As a person, a single person or multiple person team will take about half an hour to an hour to inspect a single vehicle, and we do it in seconds. And I think another great benefit is the accuracy. A person gets bored. It's a mundane task to do it over again. Sometimes you miss stuff. And with our system, we're able to get to accuracy levels that are they're simply not possible with just manual work.
Yeah. So the manual part was done by people examining the car, and I guess the drivers would tell you, I had like a problem with the tire, I scratched the car on the way, or something like that. So in the past, people were more they were more needed in order to get these kinds of information. Do the drivers think it's efficient, or do they think it's like too much information collected on their like driving? Maybe maybe they drove I know, like scratch something. I'm trying to think like for the other side of what does it mean being expected all the time. First, I guess it's done more because it's so fast, you could do it like daily, I guess. And second, what does that mean for them?
Yeah, so for the end customer, the experience is extremely positive. They get full transparency, and this is something that was really missing in the industry until we came along. What is exactly the problem? You think you're coming to a shop to repair something very small, and all of a sudden you have a bill for 10 times what
Yeah,
you expected to have.
right.
And with our system, we can really show them. The dealership and the body shop can really show them with full transparency. These are the issues. This is what went wrong, and this is why you have such and such repair cost. Before that, it was you have to trust me and you have to believe what I'm telling you because
Yeah,
you haven't seen the damage. So from the point of view of the end customer, it's a very, very positive experience. It also happens very quickly. That person doesn't have to wait a long time to get those answers. As far as the business side or our customers, the experience is also very positive because they don't get the pushback from their clients. So there's a lot of I would say trust building around the system. It helps to build trust between the business, which is our customers, and the end user. I would say that there is an interesting story from the flip side around AI and generative AI replacing jobs, et cetera, et cetera. It's not the case in, well, it might be true in the general case and in some cases, but in our case is completely the opposite. What we see is with our customers, we see increase of business. We see tangible increase in sales by using the UVI system, meaning that our system generates more business to our customers, and that even creates more jobs than vice versa. So I think that the correct way to look at our system is sort of like an assistant, a tool to help you do your job as a customer representative or a repair shop or a fleet manager, to do your job more efficiently and more quickly. And it doesn't have to do, or it doesn't have anything to do with replacing people in their current jobs.
Yeah. Would it inspect the engine itself or only the surrounding? Would it say something that is mechanical, some kind of problem within the mechanics, or it's just all around?
Okay, so if it's visually apparent, if you can see the damage, then we can report it. If it's from the engine, if it's from the undercarriage, if it's from the wheels, if it's from anywhere.
Yeah.
If it's not visible, maybe we can infer it because sometimes you have telltale signs that even though you're not really seeing the damage, it's behind some other panel, and we can also report that. We can infer there's a damage, and here the generative AI really plays a big part. And if but on the other side, there's no magic. If we cannot see the damage, if it's completely obscured, then we won't see it.
And would you get additional information from the driver? Like, say, I'm a fleet manager, and somebody tells me there is some kind of weird sound somewhere in the rear part of the car, whatever. Would you take that into consideration when you're doing the calculations and analysis?
We try to keep the system completely unbiased. So sometimes, if you have a fleet, then you have the drivers, they can report accurate and you can report not accurate. So we keep the system unbiased, and we can relate to specific parts. We can look for specific things, and we give our customers the ability to look at very, very specific things that they are looking for. But we also look at the entire vehicle every time.
I
I
see.
can add that currently UVI inspects in order of I would say several millions of cars per year. That is our current rate, and it's always increasing. And so we've gathered pretty much the largest off market database of vehicles over the years that the company exists. And this allows us to create sort of like analysis of an industry pulse. Um, um, since we're not tied to a specific brand or a specific car make, we inspect everything. And we have the ability to know what is the status nationwide or global wide of the tires, for example, or replacement card or replacement parts, or which tire brand is more prone to wear and tear, which vehicle type is more prone to wear and tear, et cetera, et cetera. And we inspect this over the entire lifetime of the vehicle, from the moment it exits the production line from the OEM factory until it gets to the scrapyard. So we are able to keep track of a specific car plate or specific chassis over the course of its lifetime. And it can be through several owners, it can be through several states, it can be from several repairs or accidents over a lifetime. And this is something that is invaluable, and it's all thanks to the widespread adoption of the system.
Yeah. I would just imagine that people would love to know what are the cars they should buy if they don't want them to be in the car shop all the time. I could tell you that my husband is I know how it's called, like it's like exploring the car in order to find like once a year you're going to get a test being done, and he's doing that within a very big fleet in Israel. And we're always saying like what would be our car, because he knows what's going to be wrong, and we're trying to find a car that you could relate to and trust. And I guess that this information that you were talking about, most people would love to know what are the cars that are broken more, and not like only how beautiful they are and how good are the ads and PR. But I guess it's part of the information that you gather, and it's not, you don't, do you have a benchmark for these types of informations?
Yeah, we have it. We have all the information. The databases are truly gigantic, and we constantly monitor the different changes, the different trends over the courses of months and years. And we look. So we gave the example with the tires, but there are numerous other examples. We can pretty much tell you what a specific brand overall, as far as the global statistics that we see for that particular vehicle, what is their status, what can go wrong, what usually happens on the normal case. Of course, every situation is a little bit different, and there are exceptions, but on the normal case, we can tell you what you can expect over the lifetime of that vehicle.
Mm. So what are some of the biggest technical hurdles you face in developing this technology? And you have so much data, so you need to manage that in parallel, I guess.
Yeah, so I think that the UVI story correlates to how a proper startup needs to build itself, especially in automotive. And I think that the first challenge was to achieve a very good product market fit, and have someone or multiple customers really fall in love with your product, and having the ability to create a very good value proposition for them. And I think UVI has achieved that. The customers are very happy. They are very satisfied with the value that we provide them. After you achieve that, or after you think you achieve that, there's the technical perspective, and it's often coupled, and because the value prop is derives from the technical advantage and development that you create. So from an AI perspective, I think there are several challenges. One relates to, I would say, AI in the real world, AI in the wild, especially in automotive. There's a term called long tail distribution, which means that when you look at the distribution of the cases and scenarios that you encounter over the lifetime of your system, of the AI system, most of the cases, I would say 80% of the cases, they happen pretty quickly. So you will be able to collect and encounter those cases quite frequently. But there's a very, very, very long tail of very rare edge cases that happen once and never, like once a year, once in 2 years, once in 10 years, or once in a lifetime. And the level of reliability and level of performance that you need to achieve usually requires you to dive very, very deep in that tail. Compromising on 80% performance is usually not a good. It's not a good product market fit. You have to be better. One of the challenges with UVI, and I think this is a common to other aspects in automotive, like ADAS and AV, autonomous vehicles and safety systems, will be to okay, so how do you solve them? How do you even find those edge cases? And how do you train your models to detect them? How do you train your models to solve them? And here comes an array of solutions. And you have to keep in mind that at the end of the day, this is a commercial company. You have to have your solution cost effective. You cannot always throw more data at the problem. You cannot always throw more compute at the problem. And you have to do it in a very efficient and very lean way in the deployment and in the development. So one of the challenges with developing AI for very hard grand challenges like automotive is figuring out how do you create the proper development methodology within your company to allow you to efficiently solve those problems. So, for example, at UVI, we have a ton of data. How do you find the interesting cases? Most of this time, most of the cases are not interesting. They are simple cases, stuff that we've solved years ago. If we keep feeding the same data to the models, it won't improve the system. On the other way around, it will hurt the system. It will create a bias towards the common and easy cases, the 80%, and it will not allow you to solve those edge cases. So one of the first things that you need to do is build a data mining system, and it has to be very efficient. How do you search on petabytes and petabytes of data? These are billions of frames and hundreds, if not tens of millions of vehicles. So first, data mining is a very big problem. And here, generative AI is really, I would say, refreshing the tools that you can employ. With Gen AI, you have the ability to search on your databases in a way that it's not possible without it. So you have simple semantic search, I would say tag-based search without it. You can train some classifiers to find some interesting cases that you want. Usually that will get you a pretty good distance within the tail distribution. But it won't find everything. And with generative AI, it gives you a different tool to search on the interesting cases that you want to find. So that is one problem. After you have that data mining system in place, now you have to efficiently train and deploy or redeploy the models. So here it depends on the product. So at UVI, we have over-the-air updates. Once we have a new version ready, we put it through a series of very, very rigorous validation and tests. Basically, in automotive, is the closer you get to production, the closer you get to real world driving, your data sets shift. At the beginning, your training data sets are usually quite larger than your validation sets. And as you get to production, your validation gets much, 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 much larger because you have to make sure that everything is okay. Safety is involved, and there are strict regulations. There are strict tests that you need to comply with, that you need to pass. And the closer you get to production, the larger your validation effort is going to be, and so your validation sets get really, really, really big. I'll give you an example with when an OEM, when a car maker wants to release a new car model, and there's a new feature involved, a new sensor involved, like a radar or a special type of feature that they haven't employed yet. They usually go through about a 1 million or 1 million kilometer or 1 million miles of data just for validation. Not for training, not for development, just for the validation, just to make sure that everything is okay in a bunch of scenarios: summer, winter, snow, rain, fog, day, night, urban, highway, in a variety of cases. So we employ the same methodology. We put our AI algorithms through many, many, many hurdles. We look at large scale KPIs. We look at specific edge cases. We look at specific scenarios. And only if the system is validated and revalidated over those tests, then we employ over-the-air updates and update our systems. So it's really about setting all of that infrastructure in place. But once you have that infrastructure, now you have the muscles and bones to tackle the problem.
Yeah. So I want to go back when you mentioned when you're using AI, which is a type of getting data, learning, and automations, which is very complex. So that's the AI part. And you say that in order to search for the efficiently within the data and to find these edge cases, you're using generative AI. Could you explain again what does that mean?
Mm-hmm.
Most
Sure.
people, when they think about generative AI, they think about a computer that would get an input-output of text, image, video, whatever. So what you're saying is something very specific. So that's why I'm asking.
So we look at generative AI as a new tool that we can use in our stack. We had classical computer vision, we had classical machine learning, we have deep learning, and then we have generative AI. And in our case, generative AI means multimodality, means that we have images, like we said, we have metadata, a lot of metadata on the vehicle, on the state, on everything, on the driver, on the history of the vehicle. So there's a lot of metadata that is involved in the system, and of course there's text, natural interface to the developer or to the user. And generative AI allows you a lot of things that are beyond just a simple conversation with a chatbot like ChatGPT. The engine itself, the LLM, is very versatile. And you can use it in our case for in the general term is called LLMs for visual understanding, using those large language modules, multimodality, in order to understand better the visual information that you have. And the example that we gave before about the edge case mining and searching on very large data sets, here there are several methods. I'll give you one example. One example is RAG. RAG is an acronym for Retrieval Augmented Generation. Basically, it means that you can search on very large databases semantically and retrieve the information that is relevant to your specific search. So in our case, the semantics can be a combination of the perception output, this is the vehicle, this is the car parts, these are the damages, and also additional information like what am I looking for? Am I looking for leaks? Am I looking for scratches? Am I looking for missing parts? Am I looking for damage estimation? And what am I exactly looking for? So having the ability to combine between a specific search query and the specific semantics that you're looking for is not possible without Gen AI. This is the tool to do it. And this is one example. There are other types of search that you can do. And when you employ all of those tools together, you get a very powerful system that gives you the ability to really find and pinpoint what you're looking for. But that is just one example of generative AI. Generative AI is usually used for, in our case, we use it for several other things as well. I think that the perception stack in general, so perception is the low-level computer vision task of identifying and understanding what you're looking at. Is it a person? Is it a vehicle? Where it is? Where is that tree? In computer vision, and also in other sensing modalities like LiDAR and radar, you usually want to get to an object level and sometimes even point level or pixel level type of understanding. What type of class is the road, and where is it? What pixels correlate to that class? If it's a LiDAR radar, what are the signals that are involved, or what are the point clouds that are involved with a tree or with a person? So currently, I would say up till the last few months or years, a year or two with the Gen AI revolution, the tools were classical computer vision, classical signal processing, a lot of model-based algorithms. Then came deep learning, completely changed how we do most of the stack. Not everything, by the way. Classical algorithms still have their place. A lot in post-processing, for example. A lot of the tracking is still classical. Mapping is usually done classical. A lot of the pre-processing before the model. So the modern AI stack looks like classical pre-processing, then the deep learning part does most of the heavy lifting, and then post-processing, like multi-frame processing, etc., which is also done usually classically. And now Gen AI. So Gen AI has the ability to transform each of those different parts. LLMs have a very unique capability to adapt and perform quite well on different tasks that are zero shot, that they haven't been trained on. And once you have the ability to fine tune them, then you really get the performance boost that you need. And we are currently exploring it. It's in our case, it's still in the research phase, which I think correlates to most of the industry or most of the industry.
Yeah.
And we are exploring different ways where we can use Gen AI to create better visual understanding, low-level computer vision task, which is quite the opposite of what I would say the poet intended, because usually LLMs do quite better at high-level tasks that are that require several steps to perform, that require understanding different in interaction between modules. And here you're asking them to do a very, very, very low-level task. Tell me where that person is. Tell me where that damage is. And this is not a natural way of using LLM, but we are already seeing a performance boost when you combine them in the optimum way. Personally, I don't think that generative AI will completely replace all of the current perception stack, just like deep learning hasn't replaced completely the classical algorithms. But I do think that we will converge as an industry, as an academia. We will converge on the optimal combination between classical, deep, and generative AI solution for perception, for visual understanding. And that's another very, very exciting avenue that generative AI can impact, not just UVI, I would say the entire automotive and in ADAS industry. I think that even going a step beyond, if you look at companies that develop companies like Mobileye, in companies that pursue ADAS system, in companies that pursue AV, autonomous vehicles, like Mobileye and Tesla, in Wave from London, for example, their use of Gen AI has radical implications. I think we're seeing in the industry, as far as autonomous vehicles and ADAS systems, I think we are on track of keeping with the Gartner hype cycle. So there's a very big hype around 2018, 2019, 2017. Then came the dip. I think today we are past the major dip, and we are closing on the plateau of productivity. And I think one of the drivers to do it is Gen AI. It sort of brought new life to problems that a lot of the industry thought that deep learning was not the answer. The data sets are too big, the edge cases are there are too many, and you have to constantly pursue more and more miles in order to get to the fault-proof system that you're pursuing. And generative AI gave some new gas in the tank to pursue those difficult cases. And I think that even going beyond automotive, in robotics in general, there's a very, very big commonality between automotive and robotics, or the way that the technology behind the scene works. Essentially, today, a car is a robot with wheels. There's compute, there are sensors. You sense the environment, you understand it, you take actions, you plan, etc. And generative AI has, in the last year or two, it's very new. It gave a renaissance to robotics. A lot of the problems that originally were thought too difficult for classical algorithms, classical machine learning, even classical deep learning, now there's a new wave of solutions, and there's a new wave of companies. If you see Israeli companies, you see US-based companies like Figure, like Manti Robotics, all the humanoid robotics, Tesla, Optimus, and Robot. These are all derived, I believe, from the revolution that we saw with Gen AI, but specifically Gen AI for visual understanding, for physical movement, for embodied AI, those kind of things.
Wow, that's really interesting, because most people are not thinking about generative AI in the context of more complex algorithms. And I guess that most people are not really going into the details of what is deep learning, what is a regular classic AI, and what is generative AI. They're just thinking it's all AI, and generative AI is more cool, more or less. That's what I think. And it's really surprising for me to hear that the robotics industry, which is very like oriented to hardware and chips, and this is the first thing that comes to my mind. And I thought that the visual understanding part was more or less solved as I saw it. But now I understand it's much more complex than what I thought. So it's really interesting.
So I think there's a very big gap between the marketing and the actual technology, as far as the automotive industry, the AI industry. The perception problem is considered the most difficult problem, but it's not the only problem. And often it was thought, or for a long time it was thought, that if you can solve perception, you can really identify very accurately everything that is around you. You'll be able to solve autonomous driving. And first, that is very difficult. Currently, there's no system that is completely fault-proof. You combine whatever modality you want, cameras, radars, LiDARs, the most expensive sensors, the most expensive compute, very, very large models. Still, you will find that in your system, you have edge cases. You have scenarios that the system does not behave correctly. But that's just one problem. When you look at the entire stack of a robot or an autonomous car, you have your sensing, then perception, then planning. Planning is also not solved. For easy cases, sure, absolutely. For simple lane following or a simple turn, if the trajectory is very clear, then yes, we've solved this. But real life is much more messy and much more varied than just the simple cases. Um, and that is not solved yet. So currently, what you're seeing is that okay. So in autonomy, in ADAS and AV, there are levels. It's usually accustomed to divide it into 5 levels: L1, L2, L3, L5. L1 to 3 is usually referred to as ADAS. L4 and 5 is usually referred to as AV, autonomous vehicles. And Mobileye, Tesla, all the major car brands, they are either level 2 or level 2 plus. Level 2 plus is somewhere in the middle
Wow.
between 2 and
That's
L3.
really surprising. You thought that they're the most sophisticated one. I thought you would say like 4, 5. This is what I thought you would
They
say.
are no, they're extremely sophisticated. Billions of dollars being poured into these problems, and yet we are almost halfway there.
Yeah.
And
Halfway. Yo, it's so disappointing. Halfway there with so much time and effort and only to be like halfway.
it's not a linear scale, but essentially there's a long way to go.
Wow.
The one of the major hurdles is L3. L3 is not just another step beyond L2. In L3, the car brand, the OEM, is liable for the accidents. It's liable for everything that happens in the vehicle. Um, so basically, the history goes back to why do we have even the L2 and L2 plus, L2 plus plus category? The Mobileye invented it. At the beginning, it was just L2, L3, L4, and then because of the liability issue, there was another subcategory that was invented called L2 plus, and all those pluses between L2 and L3 mean that the vehicle has more and more sophisticated capabilities, but the driver is still liable. The OEM is not. Um, Currently, we have L3 cars running in very, very specific places in the US highway by Mercedes. That was issued about a year ago. In China, there are several highways that were designated L3. Um, and then you can debate whether it's L3 or L4, but it's very, very confined. L4 and L5 is constantly being pushed into the future. Every year it's 5 years in the future.
Wow.
um, and the
You know
reason is
what that reminds me? Before the Tokyo Olympic Games, they said the all the Olympic Games, it wasn't the Corona, so it's like it didn't work in any case. They said that it's all gonna work only on autonomous car, and that didn't happen. And it was one of the milestones on the way that I understood that this is much more complex than what people believed at the beginning, like 5 years, 10 years ago.
Yeah, I agree. I think that the industry realized how difficult the problem is and how varied the reality is. Doing a demo is quite easy. Demo is not hard. Getting to production, that is very hard, because you have to have all of those I would say systems in place to deal with extremely large volumes of data and do it very quickly, very efficiently. um, in my mind, Tesla and Mobileye are the most advanced in the industry today. Number three will be Mercedes, and then we have Ford, GM, and some manufacturers from China and in the West, in the East.
So
Um,
I just cut you in the L4. So just to give us the two more letters on the way, L4 and L5. What does that mean?
So L4 will mean that the vehicle can drive in specific designated areas all by its own. So you would geofence like an area, and it could drive there. Usually, L3 refers to either highway pilot or urban pilot, and L4 usually is a combination of, okay, I just point to point, I'm driving from my house to your house through highway, through urban, through suburban type of vehicles. L5 it's everything. L5 is I don't need a wheel. The car drives all by itself. It doesn't have to be. It doesn't have to have prior information on that area. It doesn't have to have a map of that area. Nothing. Just completely autonomous science fiction type of driving.
Mm. So, do you think that first, when it happens, it's like, what is your bet on that?
I don't know. Every year it's 5 years into the future. So I don't want to prophesize, but I think that we have very, very interesting new tool in our arsenal as an industry, as the academia, as researchers. I think one of the most interesting companies in my mind in this area is Wave. Very, very interesting work around Gen AI for autonomous driving. And I think that the work we're doing in UVI for our aftermarkets and automated vehicle inspection is truly groundbreaking. I think that the right combination of very large data sets, AI, regular AI, and Gen AI can really help unlock capabilities that currently we're not in our reach.
Yeah. Wow, that was really interesting. What advice would you give for aspiring entrepreneurs interested in working with the AI in the automotive sector?
Okay, it's a big one. First, have a lot of patience.
Yeah,
uh,
it's
I've
like
been in
medical. I think that automotive is very, very similar to healthcare and medical, which like it's a long-term commitment.
Yeah, it's not. You have to have a lot of patience. All of those markets that are heavily regulated and have giant corporations that really control the market, they move slow, which is good for a startup because you can innovate, you can disrupt, you can really have a good value proposition if you have good technology, but you have to have a lot of patience. The business forces, they are in most cases more powerful than the technology itself, meaning that you have to understand how the market operates. There's the business analogy of the laws of physics, and you have to play by those rules. Your technology can be amazing, it can be groundbreaking, it can be life changing, but if you're not playing by the business rules, you will not likely succeed, or it will be very, very difficult to succeed. So my advice is understand the market, understand how business is made in that market, and I think that specifically in automotive, strategic collaborations are they're not nice to have; they're must have. You have to have those giant players like OEMs, like tier ones, like tier twos, multi-billion-dollar corporations, each of them. You have to have them on your side. If you're not partnering them with in day one, either your value proposition is not good enough, iterate, find a new solution, or you haven't spoken to the right person. So fostering multiple champions within those target customers or organization is key, because people switch jobs, and over the years, your champion might move to another company, etc. So you have to have multiple areas and multiple champions within each organization, and those are relationships that you have to build, and it takes years to build them. And the lastly is the technology, because it takes such a long time to commercialize in those markets, especially in automotive. The technology advantage that you need to bring has to be a quantum leap, because over time, what happens over the years, that advantage wears off. Even if you had an amazing breakthrough, over the years, other people will start to chip away. So technology by itself is, I would say, algorithms by themselves are not a big moat. Data and algorithms and good business model and the right relationship and connections, that is a very powerful moat, because it takes years to build all of these together.
Yeah. So you're saying that the importance of technology is not enough, and you need to invest in your business and your vision and the way that you see the strategy for a company much even much more because it's moving so fast, so slow, and it's not as fast as other industries.
Yeah, the technology is moving extremely fast, but the business is moving extremely slow. So the technology, your technology, has to be so far ahead into the future. So by the time that the business catch up, you will still have an advantage. Otherwise,
Mm.
they will catch up, and then they won't do business with you.
Yeah. But don't you think that in some cases these like relationships would end up in them taking parts of your idea and doing some of it for themselves?
It's always a risk, and you have to play it smart. You have to disclose only the stuff that you want to disclose, and not your secret sauce. You have to protect it, and that's why you have to build the collaborations. Eh, I really don't see, or it's not impossible, but it's very, very difficult to succeed in automotive without the right partners, the tier ones, the OEMs, the tier twos. Um, there are a lot of big players that have operated in this market for decades, for many years. They do business with each other all the time. Um, if you are a tech startup and you want to disrupt some part of the market, um, it's very wise to partner with them. But of course, protect yourself.
Yeah.
They have all of the incentive just to steal the technology and do it from themselves. They have usually a lot of teams that are working on in parallel on the same problems, and don't disclose exactly how you do stuff. But you do need to create such a good value proposition that they have to work with you.
Yeah. Yeah, I totally understand. What skills and expertise will be in high demand within the automotive industry as AI continues to play a larger role?
I think that if we look, if we focus the question on AI, then I think that specifically in automotive and robotics in general, um, the good AI engineers and researchers that I've seen, they're usually multidisciplinary. They are not just one colored. They have a diverse background in engineering, in physics. They can synthesize ideas from different algorithm families, from different types of problems, make the analogies and jump to their specific use case. So having a very wide base or foundational base in different types of algorithms is important. And I think that learning quickly is also very important. I think that Gen AI is the new kid on the block. I'm guessing in a few years we'll have something else. Constantly learning, constantly iterating, constantly improving your skill set, and not staying stagnant. You have to constantly learn. So the combination of very good foundations in multiple disciplines and multiple algorithm families, having the ability to learn quickly, and having the curiosity and hunger to do it, I think that over time this compounds to a very significant difference between the mediocre engineers and researchers and then the great ones.
And what excites you the most about the future of AI and its potential to transform the automotive industry?
I think that our conversation naturally drifted to generative AI. I think that this is the most exciting avenue in my perspective. I think that we just started with this new avenue, and I think that as this mature and as we learn how to combine it with the existing tools that we have, this can really unlock features and capabilities that we thought were simply not possible.
Wow. Okay, we're almost done, and I have like a few last questions. And the question that I usually ask all my guests: what is your number one tip for entrepreneurs today?
So I think we covered this when we talked to the entrepreneurs in automotive. I think that one strategic collaborations. The second will be in any market or any relevant market. I think product market fit at day one. Really zone in on your strategy and how to create a very good value proposition to your customers. Identify those customers. Who's my ICP, my ideal customer profile? Who are they? And who am I targeting? Really focused at day one, like laser focus on very, very, very niche, very, very specific. The opposite of scale. You need to do something that doesn't scale. It doesn't make sense to do it on the long term, but it makes all the sense to do it in the short term. Get to market, get to customers, get to revenue, iterate quickly, like an MVP approach. Don't develop years and years of technology just to end up with a mediocre product or having the understanding that someone beat you to it. And then really have the vision or the technology vision to strive very, very, very far away into the future, because by the time you commercialize, the advantage will wear off. So you constantly have to push and reinvent yourself. I think that in my experience, the best medicine for competition is innovation, rapid innovation. You will always have competitors in every market. You will always have people trying to copy you once you succeed, because you've showed them that this works. From my experience, patents and protecting your IP or trade secrets, they're important, they're good. But the best medicine for competition is rapid innovation.
Yeah. Wow. It was really, really interesting. And I really thank you for coming here. Where could people hear more about what you're doing, UVI, and contact you?
I think that our company website is great. I think LinkedIn is great. I think the combination of LinkedIn and the company website has a tremendous amount of information, and connecting via LinkedIn is the easiest way.
Sure. Thank you, Itai, for being here. It's been a pleasure having you here. Thanks.
Thank you very much. It was a pleasure.
Sure. And to all of you changemakers out there, thank you for joining us. I invite you to sign up to my new online leaders program, Unlocking the Power of Generative AI, designed to equip leaders with the skills to build successful generative AI products. And I'll see you next week with another innovative, insightful talk. See ya.